Okay, we are now on our third part of this unit. We're going to be solving nonlinear systems algebraically. Mostly we're going to use a lot of substitution. Okay? To solve a system equation using substitution, you must first understand substitution. Okay? A substitution in a sport, such as basketball or soccer, means you take a player out of the game and substitute another player in the same position, typically. Okay? The two players may have different abilities or sizes or strengths, but they can play in the same position, typically while you're doing a substitution. This is along the right lines, but in mathematics, it needs to be more formal, and you have to maintain exact equality. So I can't take something out and put something in that's kind of similar. I have to put something in that's exactly the same. So in mathematics, when the substitution occurs, the two values need to be exactly equal. For instance, we know that 5 plus 6 is equal to 11. We also know that 2 times 3 is equal to 6. Therefore, substitution, we can say that 5 plus 2 times 3 is equal to 11. We can remove the 6 and replace it with 2 times 3 because we know 6 is equal to 2 times 3. This is known as the substitution property of equality. We also have another form of the substitution property called the transitive property of equality. So if 3 times 4 is equal to 12 and 12 is equal to 10 times 2, we can say 3 times 4 is equal to 10 plus 2, Okay. So the 3 times 4 equals 12. 12 then equals 10 plus 2. So these are the two properties down here. So the substitution property says for every x, w, x, y, and z, if x plus y equals z and x equals w, we can take x out and replace with w. We're taking one of the expressions out and replacing it with what is equal to. The transitive principle of equality says if x equals y and y equals z, we're not replacing, we're taking the one to the other, to the other, to the other, and we can say it translates down the line. Okay. However, when you use these things, you're still going to use addition or elimination because it does no good for us to do a substitution if we don't remove one of the variables. And we'll show you that in this equation here, right? It does us no good to find out what x is and put it into the equation there if we can't get rid of y or vice versa. Okay, so we need to somehow be able to eliminate a variable, and this is going to work in this case because what's going to happen is, oops, let me see if I can move that over. Sometimes my stylus stops working. We're going to substitute right here or use the transitive property. So we know both these things are equal to y, so we can set them equal to each other. And I'm getting rid of the minus signs and putting plus and negative. So it's a transitive property. Okay. Negative x minus 1 equals y, and y equals x squared minus 9x minus 1. So I can put that in this case. So what happens then is the y's eliminated. Okay? And you could have, in this case, actually just subtracted the two equations from each other. But now in this problem, it's a quadratic, so we'll put it in standard form. So we have x squared. We're going to add x to both sides, and we're going to add 1 to both sides to get this. Take an x out, and you get x minus 8. And then by the zero product property, x is equal to 0 or 8. Okay. Those are the two x values. Now I don't think I'll actually write them that way yet. Let's write it this way. X equals 0 or x equals 8. The reason I write it this way is because we want to find the system. The system is not the x values, it's the points of intersection. So now I got to plug in 0. So y is equal to negative 0 minus 1, so that's negative 1. So 0, negative 1 is the solution, and y is equal to negative 8 minus 1. So that's negative 9. So 8, negative 9 is the solution. So those are the two solutions. And if you'd graphed it, you'd see that. And this one we could have solved through graphing. Okay. This one you probably could solve through graphing as well, but we want to learn how to do it algebraically. Okay, so when we do the substitution, I think one of the things I could do is I say, well, I have a 2 here, and I have a 2 here, so I could do y equals 2x squared plus 8x minus 2x minus y. Okay. But that won't necessarily get rid of an x or y value. Okay. It might or it might not. Okay. So you got to be careful. In this case, it actually would. But that's probably not the way to go. And the substitution can occur anywhere. It doesn't have to be with y or x. It can be with 2x. It can be with x squared. As long as you eliminate something, so the equation becomes simpler. In this case, we'd like to eliminate the y variable. Okay, so I want to make sure y goes away. So what I would probably do is I'd probably add y to both sides and subtract 2 from both sides, and I'd turn the second equation into this. And now, right, we'll use substitution or the transitive property to say 2x plus -2 equals 2x squared plus 8x plus -2, right? So both of those two expressions, I'm going to highlight these, are equal to y, so they have to be equal to each other. And 0 then equals 2x squared. We're going to get plus 6x. The -2's will cancel out. Take out a 2x, and you get an x plus 6, which means x is equal to 0 or x is equal to -6. And then we plug those in and choose to plug them into this one. I think that's the easiest equation to plug them into. So then y is equal to 2 times 0 minus 2, or y is equal to 2 times -6 minus 2. And so this is -2, and this is, that's not a minus sign. And this one over here is -6 minus 2, that's -14. So our solution set is 0, -2, and -6, -14. All right, so again, we need to get rid of one of these variables. So this bottom one looks like it's pretty close to being solved for y. So if I add 3y to both sides of this equation, I get that. Now I can plug this in for x in the top equation. So instead of x squared, I get 3y plus 5 squared plus y squared equals 5. So this came down here, and we substituted this in place of x. And now this equation involves only one variable. Now different degrees of that variable, but just one variable becomes a quadratic, right? So when we square this, right, you get 9y squared plus 30y plus 25 plus y squared equals 5. Right? When you square, then you get a squared plus 2ab plus b squared. And now we're going to combine some things, right? So you get 10y squared when we put these together plus 30y. And then if we subtract 5, we get plus 20 equals 0. Looks like you can take a 10 out, which gets you y squared plus 3y plus 2 equals 0. And now we're hoping that we can factor. So plus 2 plus 1. So therefore y is equal to -2 or y is equal to -1. So we made the substitution. We solved that for y. Now we're going to substitute this into the original equation. I'm going to go with this equation right here to find x. So therefore x is equal to 3 times -2 plus -5, or x is equal to 3 times -1 plus -5. So this is -11, and then this is -8. The answers are -11, comma -2, and -8, comma -1. Okay, so we have x minus 5 squared plus y minus 4 squared equals 25. So a couple things to note. That's a circle. If you don't know that, that creates a circle, and there's a line. So we might get a picture that looks like this. So there's probably going to be a couple solutions to this, but it could get a solution like this, or one that hits tangently, which would just have one solution. But that's kind of what we're dealing with in this problem. Sometimes it's nice to think of the visual, although we are doing this one algebraically. So if we solve for x, right, we get 8 minus y, or 8 plus -y, or if you want to, -y plus 8. Or if we can solve for y, we get -x plus 8. Either's fine. I guess I'll solve for y. But either way, it'll work out. Then you plug that into the other equation. So this is x plus -5 squared plus, and in place of y here, I'm going to put -8 plus negative x plus 8 plus negative 4 squared equals 25. I'm going to highlight that. So right here, we plug in this. Otherwise, these two equations should look identical to you, but we made that substitution where we took out what the value of y, the expression of y, and put in something that's mathematically equal and exact to that. So what are we getting here? Here we're getting x squared minus 10x plus 25. Here, I'm going to do this here, negative x plus 4 squared. So if you simplify that, you'd get that, right? So 8 minus 4 is 4, and then we have a negative x in the front. When we square that, what are you going to get? You're going to get x squared minus 8x plus 16, and then this equals 25. Now, what are we doing? Combining like terms. X squared minus 18x. These two 25s are going to cancel out, so then plus 16 equals 0. Okay. So I'm looking at that and thinking, okay, do I know two numbers that multiply to 16 and add to 18? I don't think so, right? Because 16 and 1 would add to 17, but that doesn't add to 18. And then anything other than that's going to be smaller when you add them together. Like 8 and 2 would add to 10, and 4 and 4 would add to 8. Okay? So the most we can get out of that is 17. So this does not factor for us. So then we're at that point, we go, did I do anything wrong? So I'm gonna, you check your algebra. Okay. So x minus 5 squared plus y minus 4 squared, and the y we replaced, right, with negative 8 plus x. Negative x plus 8, I mean. Okay. So when you plug that in, right, and that's what we're talking about right here, okay, negative x plus 8. If we then subtract 4, you get negative x plus 4. If we square that, x squared minus 8x plus 16, still good, still equals 25. These will absolutely cancel out. Okay. So we do get 16, negative 8 and negative 10 is negative 18. And then we have a 2x. There it is. So you go back and check your work and go, oh, I forgot to put the x squareds together. So now let's factor a 2 out of that. You get x squared minus 9x plus 8 equals 0. And now we can get minus 8 minus 1. So x is equal to 8, or x is equal to 1. And then using this equation up here, we can find out what y is. So then y is equal to negative 8 plus 8, which is 0, or y is equal to negative 1 plus 8, which is 7. So 8, 0, and 1, 7 are solutions to that. Okay. All right, that's our last problem to do. Give it a shot on your own, and let me know if you need help.